Hello, I am Robert Falkowitz, Director of Concentric Circle Consulting. Before we start, I would like to let you know that this presentation has closed captions. To change your caption settings in YouTube, click on the CC button at the lower right side of the window. You may even enable simultaneous translation. The French is not bad at all, although the results are amusing at times. I would like to share with you a synthesis of my experience gathered over the past 20 years in improving the management of incidents. Without further ado, let us address the question of how to go beyond firefighting, advanced techniques for incident management. To whom is this presentation addressed? If you are a beginner, starting to learn best practices in incident management, you are on the right track. But this presentation is for those who have already mastered the basics. Perhaps you are interested in learning how to apply a specific management framework to your organization. My purpose today, however, is not to describe any of those frameworks. But if you are interested in becoming a world-class incident resolver, then this presentation is meant for you. I will describe a series of techniques used throughout the service life cycle that will help you to better achieve the basic goals of incident management. These techniques are all based on common sense. However, they may require a certain amount of time to implement in an organization. If you will not be able to implement all these techniques immediately, this presentation will help you create a roadmap for future improvements. A roadmap that will lead you beyond firefighting, a vision of how to bring world-class incident resolution to your organization. Let us recall the principal goals of incident management: to restore normal service, to restore it as rapidly as possible, and to minimize the impact of incidents while you are doing the work of restoration. The advice I will provide you is meant to address some of the real issues that most organizations face while trying to resolve incidents. What is the reality of incident management that we all face? Most importantly, there will always be incidents. No matter what we do, we can prevent only some incidents from happening. Here are some of the other issues we generally face. We learn how to resolve incidents by resolving incidents. In most organizations, an incident is like a computer virus on the first day in the wild. Before anyone has seen it, the antivirus software may not recognize it and protect it against it. So it is with incidents. The first time we see a certain type of incident, we have no idea how to handle it until we have successfully handled it. There is a learning curve in resolving incidents, sometimes very steep at the very beginning. While we are learning to resolve a certain type of incident, we are failing in the goal of minimizing the impact of incidents. What can we do to shorten that learning curve and make it less steep? Even when we have learned, by hard experience, how to manage a type of incident, we still make mistakes. This is only human. We make mistakes in classifying incidents. We make mistakes in assigning incidents. We make mistakes in resolving incidents, even when the resolution steps are previously documented. All these mistakes lead to slower incident resolution. Until an incident is resolved, we do not know for sure who is able to resolve it. More difficult incidents often have false starts in their diagnosis and resolution. We think we know what to do, but sometimes we are on the wrong track. When an engineer or a technician or an administrator learns about a certain technology, such as a type of server, a database manager, a network component, or an application, it is normal to learn troubleshooting techniques for that technology. It is less common to learn resolution techniques. The assumption is that knowing what is wrong will automatically tell you how to make it right. The assumption is not always correct, especially in more difficult cases. In my experience, the weakest part of incident management in most organizations is in the restoring of normal service after the failure has been repaired. As an example, I recall the case of a bank that had to pay millions in penalties because it failed to communicate its daily position to the national bank in time, following a significant incident. The irony of the situation was that they could have done so in time, but the incident resolvers did not know the priorities for rerunning batch jobs that had backed up during the incident. The first technique I would like to discuss is the use of incident models. An incident model is simply a defined series of steps for handling a certain type of incident. Looking at the incident life cycle, the model may help us at many points. After the incident is detected, it helps us to define what symptoms need to be collected. Service desk agents are trained to ask such questions as, when did you first notice the issue? Have you seen it before? Do any of your colleagues have the same problem? And so forth. An incident model may define much more specific questions to ask, especially when the answers, the symptoms of the incident, help to distinguish one type of incident from another. These more detailed symptoms might include events occurring just before the failure, or conditions simultaneous with the failure, or a prefix to an error message, or any number of other symptoms. The model might define the questions to ask, or even provide a diagnostic script to help collect more symptoms. Once the symptoms are gathered, the classification of the incident may be included in the model. The classification might include the expected impact, hints for determining the urgency. Urgency must always be determined according to the current context and can never be hard-coded in a model. In addition, the classification might include the services impacted, the configuration item categories concerned, and any other useful classifications. If the incident needs to be assigned to a second line of support team, the model should indicate to which team or person it should be assigned. This feature may save much lost time due to incorrect assignments. The model should include information about how to resolve the incident, either embedded in the model document itself or with a link to an external knowledge base with that information. Finally, the model may provide information about how to restore the services once the fault has been repaired. As with the example given above, restoring services is a critical part of incident handling. Many organizations already use incident models to a certain extent. Sometimes they are embedded in a troubleshooting section of a standard operating procedure document. They would be more useful if implemented as a template in the incident management tool. Selecting that template automatically completes many fields in the incident record. Indeed, in some cases, the template could also trigger a script or application that automates the resolution and recovery. The result of applying the information in the incident model is both a shortened duration for the incident, but also a more predictable duration. The cost of creating and maintaining incident models is paid back in shorter incident resolution times and reduced incident impact, especially when the incident type is likely to recur. The value of having more predictable resolution times becomes particularly important when a service provider commits to those resolution times in a service level agreement. We define resolution time as the elapsed time from the detection of an incident until its resolution. It is not the same as repair time, which measures the time from the completion of the diagnosis and the execution of any necessary logistics until the resolution. Many organizations base the agreed resolution time for an incident on the priority of the incident. Often, they use a scheme where priority is determined on the basis of incident impact and urgency. The priority of the incident is then used to determine how quickly it ought to be resolved. In many organizations that do not use terminology according to ITIL, priority is sometimes called severity. I have frequently discussed with IT personnel the implementation of such a system. Often, the specialists tell me that it is impossible to agree to any fixed amount of time to resolve an incident. This is especially true of people playing a third line of support role, such as application developers. They believe that the only reasonable agreement is to make their best possible effort. Is there a logic to this argument? Should we listen more closely to our experts? Let's look at the situation more closely. Suppose, for a given incident, the urgency falls after the normally expected resolution time. In other words, we might expect an incident to be resolvable in 1 hour, but the urgency of the incident is that it be resolved in 2 hours. In such a case, there is no real issue. By the way, in such cases, the urgency plays no real role, if we always resolve incidents as rapidly as possible. But what happens if the urgency is in only 1/2 hour? Since it will require 1 hour in any case to resolve the incident, it means that our system for calculating what represents good and agreed practice will fail to minimize the impact of incidents, as is our goal. The issue is that basing agreed resolution time on priority is a method based on the average value of the incident resolution times. This approach might be good enough for some organizations, but for organizations that want to do the best possible job for all incidents, I think we should look for a somewhat different approach. Instead of basing resolution time on incident priority, we could base the resolution time on the type of incident. Incident priority would be reserved for its original purpose only, to determine in which order incidents should be handled. Each incident type is potentially different when it comes to the best possible time to resolve it. Therefore, we propose that the incident type corresponding to an incident model be identified first. Next, the estimated resolution time is retrieved from the model, and the estimated recovery time is published. Based on the real-life experience of resolving such incidents, the resolution time can be tuned and adapted. In this method, an IT organization is judged based on how well it should be able to perform for each incident type. It is not judged based on a somewhat arbitrary average value applied to all incidents. In any case, it seems somewhat unfair to base resolution time on urgency, given that urgency is completely out of the control of IT. For example, for a certain type of incident, say a memory error in a server, it is determined that the quickest and least painful way to resolve it is by rebooting the server. Furthermore, it is determined that a full reboot takes a minimum of 15 minutes before the services are available again. For this type of incident, the agreed resolution time could be set at 15 or 20 minutes, independently of the impact or urgency. For another type of incident, resolution might depend on running a script that resets the state of an application. This might take 10 minutes to run and to check. A high-performance organization should be willing to accept an agreed resolution time of 15 minutes for this incident type. Finally, the resolution times of some incidents are extremely unpredictable. For example, an incident due to an application bug, one that has corrupted data and for which no real workaround is available, might require an unknown amount of time to find a reasonable solution. In such cases, is it ever reasonable to expect anything other than best effort? We can manage the amount of time it takes to resolve such incidents by more direct means than by linking them to priority-based resolution times. It would be more beneficial to reduce application complexity, to ensure application standards, to better document applications, to manage technical debt, and so forth. In other words, it is better to create systems that are simple to diagnose and repair, and to consider the types of incidents that might occur when the system is being designed. According to the cost of quality method, the best and cheapest way to achieve a given quality level is to design and build for quality. Similarly, the best time to consider what incidents are likely to occur and how they ought to be resolved is during the design phase. Many different methods may be used to this end. One of the most common approaches, used throughout the engineering world, but only rarely for IT services, is failure modes and effects analysis. FMEA was originally developed as a military standard, but its most recent avatar is in a standard of the Society of Automobile Engineers. Here are the references to this standard in case you wish to find more details. Here is a simplified overview of FMEA showing how it may be used to contribute to the creation of incident models. We start by defining how a system should behave. What are the expected behaviors? Next, we identify the sorts of things that could go wrong in the system. In other words, what types of incidents might occur. For each type of erroneous behavior, what would the effects be? And for each effect, how would we rate its impact? FMEA uses the word severity, but the intention is the same as the use of impact in ITIL. We want to know the likelihood of the incident occurring, and we also want to determine the likelihood of the incident being detected. On the basis of these factors, the effects, the impact, and the likelihood of occurrence and detection, a priority is assigned to each case. For the types with the priorities that we choose to address, an analysis is made of the controls required. Some controls may serve to eliminate certain weaknesses that may result in faults. Other controls, however, may be used only during production. Several of these steps lead directly to information that may populate an incident model. What should happen describes the normal service definition by which we may judge if an event is an incident or not. What could go wrong defines the incident type. What is the impact defines the default incident impact. How likely is detection helps us to identify the symptoms by which the incident type may be detected. What controls are needed may define the resolution steps for the incident type on the assumption that controls will not serve to prevent the incidents. Remember that good design may help to eliminate many potential incident types, but we cannot eliminate all incidents. In short, the time to start considering what incidents might occur and how they ought to be resolved is during the design of the service. When this work is done at design time, as is the standard practice throughout the engineering world, we have a chance to shorten the learning curve for resolving incidents, making even the first instances of an incident resolvable in a predefined way with a predefined duration. Designing how to handle incidents during the design phase will be beneficial if, in particular, the incident resolutions are tested and practiced in advance. This advice should not be astonishing. After all, schools and businesses have fire drills before having to put out fires. In many regions of the world, there are regular earthquake drills. Business and IT service continuity plans are supposed to be tested in advance of any catastrophic events. So why should it be so strange to test and practice the resolution of incidents? Many organizations might object that they hardly have the time to practice something when they are involved in doing the real thing. This might be true, but it only indicates that the organization is not very far along in its journey toward world-class incident management. Others might object that incident drills are purely theoretical, but of no practical value. I refer those skeptics to a piece of free and open source software called Chaos Monkey, designed by the video streaming company Netflix. Chaos Monkey introduces a variety of different incidents at random into the Netflix production environment. Its precise purpose is to give the production personnel practice in diagnosing and resolving incidents. The success of Netflix in maintaining highly available services is undeniable. Even during the recent and well-publicized outages of Amazon's AWS, on which Netflix depends, the company was able to maintain the availability of its service. In short, practice makes perfect. Let us summarize the techniques we have discussed and see how they are integrated throughout the service lifecycle. First, the service provider must commit to the strategy of high-performance incident management. During the design phase for a service, incident models impacting that service may be identified and built. Next, the models may be implemented in management tools, such as the ones used for incident handling. The model should be tested during the transition phase. While in operation, the models are used to handle incidents in a rapid and predictable way. Practice should start before going into production and should continue during the operational phase. Together with tuning of the models based on actual experience, this will ensure feedback for continual improvement. Using these simple techniques in an integrated way may seem like an unachievable challenge for organizations overcome by its purely reactive responsibilities. They demand a commitment to use resources more proactively. As such, implementation should probably be done gradually, building from success to success, starting with the low-hanging fruit. For unless such methods are used to improve incident management, an organization will have great difficulty in getting beyond firefighting. I thank you for your kind attention and welcome your remarks and questions.